So welcome to week 7 and our first week dealing with the MSP or max signal processing components of max MSP. And so this will be a lot of fun as we get into the sound world, not the MIDI world, but the actual sound world of dealing with digital audio, generating digital audio, capturing digital audio, and so on. So the first thing we need to do when we start opening up the MSP world of Max MSP is we need to make sure that we've got a digital audio system that's connected to Max on our computer. And so the first thing I would do is go to my options menu, and under the options menu find audio status. And audio status will bring up a panel that will look something like this. And this panel allows you to set up the drivers that you need for your audio system and your input and output devices. Now on the Mac, it'll almost always be the core audio driver. It'll be different things on Windows. It might be ASIO. It might be a particular interface that you've got set up which has its own driver. And then you will need to select the input and output devices. So you can see on mine, my input device, I'm using the Scarlett 6i6 USB audio interface. So that will be what I use. The microphone's hooked up to that. And that's also where my speakers are hooked up. But I could also choose just the built-in output, which would come out of my computer's built-in speaker, the speakers that are in my display or in my other display, or a number of other things that I've got set up here on my system. Yours will probably not be quite, your list probably will not be quite as long as mine is. In any case, you can turn your audio system on with this this panel, or you can turn it on with this button in the bottom right corner of your window, or, which is probably the best, you can turn it on by objects within your patch. Now, either your audio system is on and you can capture sound and generate sound, or it is off and you will not have any sound coming in and out of your system. It can't be sort of partly on and partly off. It's one or the other. And any of those mechanisms can be used to turn sound on. You can bring up the audio status panel and turn it on there. You can click on the bottom right corner of your screen to turn it on, or there are certain objects within a patch that will turn your audio system on. So for example, this one, which is the ADC tilde object, or this one, the DAC tilde object, will turn your audio system on. And when I click on that, the audio system is on. You can see right away here that I'm getting values in my meter tilde object that show me that I've got signal coming in. And I've got a second analog to digital converter here, just called the ADC tilde object, with two arguments, 1 and 2, which are the channels, and it's also turned on. I can stop it, and now the entire audio system stops, and I can start it, and now the entire audio system starts up again. Okay, so this microphone object, as I said, is called the Easy ADC tilde, and this is the EZ or Easy DAC tilde. I would generally suggest using these because there's a nice graphical depiction of whether the sound is on or off. You can also use the DAC tilde, which if you're using more than 2 channels, you should use this. This is arguments 1, 2, 3, 4 would mean I've got outputs that could go to 4 different places, and I've got then 4 inlets where I can put signals to a 4-channel system. And likewise, the ADC tilde 1, 2 has got 2 channels of input. Since I only have one microphone and it's coming in channel 1, you can see in this live gain object that I'm only getting a signal on channel 1. Okay, so that's the first thing. If you can't get audio working, then there's a problem. And I'm just going to pull this over so you can see that when my audio is on, I will get a blue. This will be highlighted blue. And if I did have signal going out, wait, let's do that. We'll connect this up. The output from my live gain going into this gain slider, put up some volume, and you can see down here that I am getting some signal going out to my speakers, which you're also hearing duplicating my incoming voice. Okay. And I guess as a little reiterating what I just said, this important note here, just be aware that the way the Max audio system works is that when it is turned on, when you've got your audio system turned on, all signal objects in your patch, any open patches, will be working. And they will be outputting values at the sample rate, which is typically 48,000 or 44,100 samples per second. Even if those values happen to be zeros and you're not hearing anything, all the signal objects are operating at a very, very fast rate. So I'm going to go back here just momentarily to my audio status, and I'm going to bring it back over here and just look at the middle part of this. I've got my scheduler in overdrive. I would recommend doing that. The I/O vector size and the signal vector size are just two settings which control the size of buffers that are used for the signal objects themselves and for communicating I/O, input and output. If your computer is laboring, then you can change these values. You can increase the size of these buffers. When you increase the size of the buffers, you will find that your computer has an easier time of it, but there will be more lag between inputting incoming signal and outgoing signal if you make these larger, simply because the buffers which are storing the data are larger, and you fill the buffer and you pass that buffer on for example, for output. Okay, if this becomes a problem, let me or Michael know. Whatever values are set here as initial values are probably fine. If you have an extremely complex patch, you may have to increase these. This is your CPU. You can see my CPU here is running at 1%. There's not much going on in this patch. I have some of my patches have over 3,000 signal objects running, and then this will be up quite a bit higher than that. And you'll see I don't know if I can make this work or not. If I change my vector size down to something smaller, can I get my CPU? Oh yeah, so it's gone up to 2%. Make this something like that. Okay, 2 and 3% because I've made my signal vectors smaller. So the computer has to work a little bit fast, a little bit harder to keep that data going through. Has to be updated more frequently. So a larger buffer size simply gives me a little bit more flexibility. My computer doesn't have to work quite so hard. All right. So let's look at some of the important signal objects in Max MSP. And you'll notice that all the signal objects have a tilde at the end of their name. So this is an ADC tilde, this is a DAC tilde, up here we have a signal tilde, cycle tilde, and so on. One other aspect of signal objects is that, in fact, they are putting out floating point numbers, but they're not the same as the flow-num object. In fact, if you were to actually determine what kind of values are coming out of the signal object, they would, if they're audio, they're generally going to be values between -1 and 1. So if you imagine a waveform, the maximum amplitude that you would get is basically a value of 1 on the positive side and -1 on the negative side. Okay? If you're using your signal object for something other than sound, like a control of sound, then of course they can be different values, frequencies, for example. But they are internally, they're floating point numbers. All right. So let's look at some of these simple objects. The cycle object, cycle tilde. When my audio system is turned on, my cycle object will output by default a sine wave at whatever frequency is put in here. and I can put integer values or floating point values or signal values into my cycle to change the frequency that it's generating. And these are not pitches, they're frequencies in hertz. So remembering that, C is around 256, A above that is your A440, and remembering how frequencies work. An octave below A440 would be A220, an octave above A440 would be A880, and so on. Okay. So and we always use some kind of gain control, either the live.gain object, which is a Ableton object that's been introduced into Max, or just the gain slider, because we want to make sure we can control our outputs and we won't have crazy signals coming out. So I am going to start by disconnecting this for now, and I'm going to connect my cycle object up to this gain. And you'll notice that the signal objects all have a dotted a cable. So their patch cords are you can identify them. They're a different color than the standard patch cords. I've got, under my debug, I've got my signal probe on, and that's very useful because when I put my cursor on top of a signal, it will actually show me the output from that object. And what's happening here is the cycle object is putting out an oscillating signal, a sine wave that goes to the maximum value of 1 and then down to the maximum value of -1 continuously at a rate of 400 cycles per second. Okay? And since my audio system is on and I got that, I do this and I can hear the audio signal coming out. If I change the frequency, I get that. Here's a different frequency. Okay. I'm going to disconnect this for a moment and just put a line tilde in. Okay. A line tilde is similar to a line. It takes a pitch and it takes the destination time to get there. So I've connected this up to the line, and even though it's a signal, it'll be understood as being frequency. So I'm going to put a value into my line. Let me give you some volume. Put a value in here of 1,000, 700, 200, and 440. Okay, and I'll put my gain down. Now the important thing is that, remember I said that signals are always generating audio at all times when they're turned on. So when I go to this and I hold my cursor over it, I can actually see a display which shows me that in fact this signal, this cycle object is putting out values. Whatever was last going into this to set the frequency is going to be the frequency that's put out. And there you can see it. Even though we can't hear it because I turned this down, but it's still coming along this patch cord. Okay? And in fact, all of these signal objects are outputting values all the time. And that's a very important concept because it's something that can lead us to make mistakes, not realize that a particular signal object is putting out a value of 0, and that's being multiplied by some other object, and the result is 0, and we don't hear any sound. Signals can be sent out at 0, and it is actually a valid signal. It's just extremely quiet. In fact, it's so quiet that there's no sound at all. All right. And I'll be mentioning that again and again as we get further into the whole digital audio world. Okay. I wanted to mention the signal tilde object. And the signal tilde object is a very simple object that simply puts out a constant signal. So I can set it to something, a 1, 100, 400.5. And this basically constantly puts out a value of, you can see it. It constantly puts out a value 400.50. And you can see it not just once, but over and over and over and over and over again. For every sample of our audio system, it's putting out that value. Now, it's not going anywhere right now except into this number tilde object, which will display a signal value. But it could be going somewhere. It could be going, for example, into here. I can't do that. I've got to go from here. Cycle 1, you're not going to hear because it's too low, but there's 100 and there's 400.5. Okay. And I'm going to disconnect that. Cycle's still working until I turn down the volume, and then we don't hear it. Okay. Now, so the reason that actually the signal is coming out of this object, the number tilde does not pass through the same rate of output as the signal object does. All right. So signal tilde, it's really just used for when I want a constant value for some reason. The line tilde when I want to create ramps of changing values, which are updating. Not remember the line had a grain value, which updated, let's say 10 times a second or 30 times a second. Well, the line tilde updates at 44,100 times a second or 48,000 times a second. In other words, it updates its value at the audio rate. Okay, now one other feature of audio signals that has been built into Macs is that when you put two audio signals into the same inlet, they are added together. Okay? So you don't need to explicitly use an object such as the add tilde if you want to add two audio signals together. So for example, let's take this cycle running at 400 and a phaser. Well, what's a phaser? A phaser goes from 0 to 1 over and over and over again. And if you imagine what that does, if you run it at, let's say, 200 or 300 times a second, it creates what we call a sawtooth wave. So this would be a sawtooth wave. And maybe I'll just put this into my output and we can hear it. Now, if I also put my cycle into the same inlet, running it at 800, we hear both of those. So they are added together. And one of the nice things about digital audio is if we have two audio sources and we add them together, we actually hear both of them, even though there is one single composite waveform. In other words, if I put this signal up and I look here, I can see that there's a waveform coming out of, it's just a single waveform, but it actually includes both of those sounds within it. Okay, I hope that's clear. So you do not need to explicitly add together two audio signals. In fact, in the very first versions of Macs, which were running in the 1990s, you did have to actually explicitly add together signals if you wanted them added. But Macs decided that it was kind of an obvious thing to do whenever you put two signals into one inlet. So they just decided to build in the automatic add when you do that. Okay, good. So I'm going to disconnect this and disconnect that. Multiplication. All right. So when we add two signals together, we get a composite signal. If we multiply a signal by a value, let's just think about what would happen if I have a signal. Let's say it's a fairly loud, it's got a fairly loud amplitude to it, and I multiply it by 1. Obviously, what happens is every single sample is multiplied by 1, and we get exactly the same thing we started with. If I take a signal and multiply it by 0, then all the values become 0. If I multiply it by 0.5, then all the positive and negative values end up being half of what they would be. So my curve that went up like this will now go only up half the distance it was going before. So multiplication essentially scales the amplitude of a sound. If we multiply it by a larger value, it gets larger, and if we multiply it by a value less than 1, it gets smaller, down to the point where it becomes 0 and there's no sound left. So I can basically simulate an amplitude control or a gain control by putting a signal into a multiplier and being careful with my multiplication values that I don't go above 1. And we're hearing nothing now, even though the gain is up. And that's because by default, this is being multiplied by 0. And as I increase this, and you notice that I can go negative as well, because if I multiply it by -1, it just flips it. The phase gets inverted of my waveform, but in fact it sounds the same. And if I multiply by -0.5, it gets flipped and half the amplitude. So that's important. Multiplication of audio signals tends to well, it does. It operates on the amplitude of the audio signal. Okay? This is really useful if we look at something like the line tilde object. And the line tilde object can take not just a single list of values, but it can take a complex list of values which really represent value, destination and time, destination and time, destination and time. So we can actually make complex graphs using line objects. So let's look at this first one. Going into a line tilde. Line tilde is going into a multiplier. Okay, the idea here is that rather than explicitly saying, let's multiply this signal by 0, or let's multiply this signal by 0.5, or let's multiply this signal by 1, we're saying, let's multiply this signal by a changing value. And that changing value will end up being an envelope, an amplitude envelope. It will, as we move up from 0 to 1, for example, it'll make the signal louder. And then when we move back down slowly to 0, it'll make the signal quieter. So let's look at this. This says 0, 1 dot, so it's a floating point, 1 in 5 milliseconds, then 0 in 1,000 milliseconds. So that's saying, let's start at 0, and in 5 milliseconds, let's go up to 1, and in 1,000, I should do it this way, so it makes visually easier for you. Let's go up in 5 milliseconds. And let's, over the next 1,000 milliseconds, let's go down to 0 again. Okay? So that, the output of that line, those values, will go into the multiplier. And let's put this into here. And I'm going to disconnect this one. I've got signal there, so when I click on this, and this is the noise tilde object, which generates white noise. So let's click on that and we'll hear this. All right, so you can hear a very quick attack and then a gradual decay back down to 0. This one says, let's start at 0 and let's go in up to 1 in 100 milliseconds. Then let's stay at 1 for 800 milliseconds, and then let's go down to 0 in 100 milliseconds. So up in 100, stay there, and then down. And it sounds like this. Now this could be used for any of these objects. So let me disconnect that for a moment. I could take the cycle over and put the cycle in here as well. Change the pitch. Or I could do something like this. Whoops, I haven't got that hooked up. Okay. Okay, so you get the idea. I can impose an envelope on any of the signals that happen to be going in. So again, because we have two inlets coming into this object, we are adding together the output from the noise, which is a random frequencies, a full volume, and the output from the cycle, which is an oscillator running still at full volume. And we add those together, and we use the line to basically to create a an envelope, an amplitude envelope on them. Okay, so we could add the phasor in as well if we wanted to. Now we have 3 signals. I'll bring them all in here, and let's make this move really slowly. Let's make this move over 2,000 milliseconds. All right, so we can do anything we want with these particular objects, the cycle object, the phasor object, the noise object, and there are a number of other objects that generate sound. Okay, so the important things from this video are understanding the audio system, being able to turn your audio system on and off, understanding that all signal objects have a tilde in their name, and that's what designates them as signal objects. Notice that I have to write multiply tilde here, plus tilde here. I can't just write a plus object. Max will not allow me to put signals into an object that's designed to take floats or integers. I need to use the signal version of plus if I'm adding together signals. Okay? And then understanding that when we have multiple signals going into an object, they're simply added together. Understanding that when we want to change the amplitude of a sound, including making it go all the way down to 0 so we don't hear it, we perform a multiplication on it. And that multiplication has basically the effect of expanding or contracting, compressing the waveform. And when it's all the way down to 0, we've compressed the waveform so that it's at 0. And this is very important. This is still putting out zeros. even though we're not hearing anything because it's 0. And if I look at this meter, it's telling me that it's 0. Okay, it's not inactive. It's actually putting out 44,000 or 48,000 zeros every second. But because they're all zeros, when I connect it into my audio output, I don't hear anything. Okay? Be careful with your audio signals that you don't suddenly multiply them by 360, because that will be a loud, distorted sound, which will probably not sound particularly good. You will get to know these objects well. Make sure when you have inputs to your system like this microphone and outputs to the system like this speaker, that you always have some kind of meter and some kind of volume control. This is essential for all good audio patches. If you don't do that, you'll risk suddenly kind of sending a very, very loud signal to your speakers, or not being able to figure out why you're not getting any sound. The meter tells me here that, yes, I've got microphone signal coming in. It's not going anywhere, but it is coming in. I could do something like this. I'm going to disconnect all of this, and I'm going to attach my microphone signal coming out of here into here. I'll disconnect the noise too. So what I've got now is I've got my audio, my incoming signal from my microphone going in here, and this going out to my speaker. And what will happen is that I can use this envelope to just open up 1 second of my sound. So as I'm talking and I click on this, you'll hear 1 second of sound. And here's another example where you're hearing a little bit of sound, and then it disappears. I don't know if you can hear that, how clearly you can hear that, but because you're hearing my microphone directly, but you're also hearing my microphone coming through the audio system. All right, there's a lot there. Please look through the tutorials on the basics of Max MSP, or the basics of the MSP part of Max MSP, the basics of audio, because they will be a big help in understanding the fundamentals of this component of the course. Thank you.